For the warm-up, just because we need the review, and this is coming up on the next cumulative. Okay, I don't know if you guys noticed on cumulative parte number 5, we only had what? Equations and systems. You guys notice that? Did we have any other polynomials that you see on the warm-up? No. Well, guess what? For the next assessment cumulative, we are going to have all of those, including equations and systems. So that's why I'm bringing these back to see how well we remember our terms in regards to, our concepts in regards to polynomials. Thank you.
After lunch.
After lunch?
Yes.
Okay, thank you. Avro, come forth. After lunch. Okay? Alright, here we go. I'm going to go over the warm-up. Number 1, it says, look up to the screen. Can you get the light? No, please. Which pair of factors of 12 has a sum of -8? So let me go over the process because I still sense some of you are having difficulty with this one. Okay, here we go. First, start with the factors. What does the term factors mean? 2 or more numbers that multiply, right? But in this case, I need 2 numbers that multiply. So what 2 numbers multiply to give me 12? Let me give you all the possibilities. 1 times 12, 2 times 6, and 3 times 4. And of course, if I continue, then reverse it, 12 times 1, 6 times 2, and so on and so forth, right? So those are the possibilities. So out of those 3 sets, which one of them can we add or subtract to give us -8? Let's see, could it be this one? If we subtract or add, that gives me -11 or 11 or 13. So it cannot be this one. Could it be this one? If we subtract, it's going to give us -1 or 1, so it cannot be that one. So it has to be this one. However, the answer has to be -8. So what do I do to these 2 numbers? Change into negative. So my numbers are -2 and -6. Let's see if it works. -2 times -6, that's positive 12. And -2 plus -6, that gives me -8. Hands, have you got that? Okay, good. Let me go to number 2. I'm going to zoom in. For this one, it seems like our noodle gets a little rusty, so here we go. I'm going to go over this one more time. And I'm going to start by distributing the exponent. Yes? Here we go. I'm going to start with the numerator. Distribute. X to the positive 9, because -3 times -3 is positive 9. Y to the -9. Are we there so far? We're done with the numerator. I'm going to the denominator. You have a radical. You have a variable inside of the radical. Now this one has an exponent, and we have the index of 5. So what happens with these 2? We divide. So 30 divided by 5 is 6. So we're left with y to the 6. Chance if you got it to right there. Okay, good. We're still not done. Still need to simplify. So check this out. Is there another x here? No. So therefore we end up with x to the 9th. Okay. Are these the same base? Yes, they're the same base. What happens to the exponent? Subtract. Now some of you made a mistake and wrote y to the -3. But that's incorrect. Why? Because we're subtracting. -9 minus 6. So what is -9 minus 6? -15. You got to be careful with this one. Try and get your noodle back on track. Okay? So therefore, we end up with x to the 9th, y to the -15. Can we leave it as a negative exponent? No. So this one has to go to the denominator. So we end up with our new expression going this way is x to the 9th on the numerator, and the denominator we got y. Instead of being a negative, becomes positive 15. And we got that. Okay, good. Let me go to number 2. 2b, I'm sorry. Example 2b. For this one, let me make some room here. First, Can we have an exponent as a fraction? Yes, but the numerator has to be a 1. So I'm going to rewrite this. This is 27. This becomes 1/3 times 2. Do you agree with that so far? Yes. Now, why does this have to be with a numerator of 1? Because we know how to rewrite this as a radical. This becomes cubed roots of 27. From there, bring down the exponent of 2. Why is it so important that this is a 1? Because it tells us that the index, and it tells us the index, what number times itself to multiply to give us the radicand. So one number times itself gives us 27. 3. Bring down the exponent of 2. So what is 3 squared? 9. Alright? Plus. What is 0 divided by 3? 0. 8 to the 0. Any number to the 0 exponent is what? Tell your neighbor, please.
1.
And repeat that again. Any number to the 0 exponent is what? Tell your neighbor. 1 is correct. So therefore, 9 plus 1 is 10. Make a note for yourself, because some of you are still kind of confused or you forgot. Any number to the 0 exponent is 1. You good? Quick review, yes? Coming back? Alright. Go to number 3. Number 3. Multiply. I'm going to use distributive property, but of course on the next assessment they're going to ask for area model, yes? So here we go. Y times y, that's y to the second. Y times 15, that's positive 15y. From there, negative 12 times y, that's negative 12y. Negative 12 times 15, negative 180. Can I combine like terms? Yes, right here. So I'm left with y squared. 15y minus 12y, that's positive 3y. And bring down negative 180. Hands if you got that. Okay, good. Number 4. What is a times a to the second? What is a times b? Positive ab. Alright. Next. What is b times a? ab in alphabetical order. What is b times b? B to the second. Can I combine like terms? Yes, these two right here. So we bring down the a squared. What is ab plus ab? 2ab, and bring down the b squared, and I'm done. Hands if you got that. Okay, good. Number 5. And zoom in. They want me to factor by grouping. Here we go. Factor by grouping. To factor by grouping, what is step 1, everyone? Standard form. So I'm going to do standard form really quick. So where do I start? At negative 5y cubed. From there I go to positive 40y squared, to positive 6y, and negative 48. From there I group these two and these two. Alright, so looking at these two right here, what is my greatest common factor? 5y to the second. However, if the first term has a negative coefficient, we need to factor that one out. So this is negative 5y to the second. Therefore, negative 5y to the third divided by negative 5y to the second, we're left with y. Negative 40y to the second, positive 40y to the second divided by negative 5y, we're left with negative 8. Next, TCS for these two, 6, and we're left with 6 divided by 6 is 1, so we're left with y. Negative 48 divided by 6, that's negative 8. Therefore, my factors are, what's the same here and here? y minus 8, so that's my first factor, y minus 8. And what's left for both? Negative 5y to the second plus 6. And these are my factors. That one and that one. Okay? Alright? And last but not least, number 6. Now this one, once again, I think one of the issues with this is that some of you still haven't memorized the terms of the polynomial, how to classify it. So I'm going to go over this one more time. We're going to revisit some of the steps in a little bit just to refresh our memory. So here we go. It says, write in standard form, identify the leading coefficient, and classify. Alright? To write in standard form, we need to identify the degree of each term. Can you leave that iPad alone, please, Julian? Thank you. So I start with this one. What is the degree for this one? 3. Tell your neighbor why that one is 3, please. Alright, Ryan, why is that one a 3rd degree? Help him out, Samantha. Because y to the second is a 2 and x has a 1, so 2 plus 1 is 3. So therefore, the degree of each term is the sum of the exponents on the variable. I'll repeat that again. The degree of each term is the sum of the exponents of the variable. Tell you never what I just said, please. Alright, let me go to the next one. What is the degree for this one? 1. Degree for this one? 0. And degree for this one? 2. Okay, now that I have the degree, I'm going to rewrite the expression according to degree. What's the highest degree? 3. So I write negative 3xy to the second. What is the next degree down? This one. So I write plus x squared. What is the next degree down? This one. So I write plus 2x. What's the last one? Plus 23, Michael Jordan. This is standard form from highest to lowest degree. From there, they want me to identify the leading coefficient. First of all, once it's in standard form, I look at the first term. Here's my first term. The leading coefficient. First of all, coefficient is a number that multiplies the variable. How many variables do I have? These 2. What number is multiplying here? Invisible multiplication. Which one is multiplying the variable? Negative 3. So my leading coefficient is negative 3. Last but not least, I need to classify this. Classify. What does that mean? Give it a name. It needs a name. First of all, by degree, and the last name is by the number of terms. So let's look at it. What is the highest degree of this polynomial? 3. That's the highest degree. Therefore, this is a cubic. How many terms does it have? Let's see. 1, 2, 3, 4. If there was only 1, it would be a monomial. 2, it would be a binomial. 3, a trinomial. But since it's more, it's a polynomial. Is it coming back? Yes? Okay, we're going to do some more practice in a little bit. So, show me with the fingers how comfortable we are so far right now with polynomials. I'm revisiting polynomials, okay? Alright, so, before anything else, draw me an emoji as to how you feel so far with polynomials before we move on to adding a quick review. Draw it and then send it in. Give you 30 seconds. Lock your toolbar, and it says find the degree of each monomial. Bless you. So write it on the screen first, the degree of each of those. Before you send it in, copy it on paper. As soon as you copy that, send it in. You have 40 seconds. Here it goes again. It says example 1. Find the degree of each monomial. On your screen, you're going to write the number of degrees for each of those. Once you write it, before you send it in, copy it onto your paper, and then send it in.
All the left steps?
Except the steps.
Okay.
You don't have to copy the steps. You already have them. No. Copy that, and go. So answer was 3, 1, and 3. Most of you, I see that you answered that. That's good. We got it? Alright. I'm going to send you a blank screen. What? Example 2. Lock your toolbar. Now for this example, I want you to identify, you don't need to write this down, identify the degree. Everybody ready? Here we go. 4x plus 7 plus 6xy to the third. Identify the degree. (20 seconds). Copy that and go. Here goes the incorrect answers on your screen. Now let me show you the correct answer. Ready? There we go. The correct answer is the 4th degree. Talk about your neighbor, let them know how they got 4th degree of that polynomial. Okay, let's see. Julian, elaborate. How do we get 4th degree? Set it in standard form. Uh-huh. Okay, but how do we get 4th degree? Marissa? By adding the exponents of x and y. Okay. So if I add the exponents of x and y, so we got x, we got 1, and another one, that's 2, plus 3 of y, that's 5. Okay, nice try. Fatima? Okay, so I keep hearing it needs to be in standard form. But what if It wasn't in standard form. What if it was like this? And I said, find me the degree of this polynomial. And I said, the degree of this polynomial is 4th degree. Tell your neighbor how I got 4th degree, please. Okay, here we go. First thing I would do is find the degree of each term. What is the degree of this one? 1. Degree of this one? Degree of this one? 4. Therefore, see what I did there? The degree of this polynomial is the highest degree of them all. What is the highest degree of those? 4. That's why this is a 4th degree. You got it? Okay, let's do another one. Copy this. Do this on paper. Example Super Q. For this one, I want you to find the degree and the number of terms. Let's see if you remember that. Here we go. Ready? Let's do 7a plus 5 plus 2ab plus 6b to the 4th minus 7a cubed b squared. Find the degree and the number of terms. Copy that and go. Correct answer on your screen is right there. 5th degree and 5 terms. Yes? 5th degree, 5 terms, and so on and so forth. Okay? And lastly, let me send you a blank screen. This is a quick review. Let's see how well you remember the algebra tiles, because we're going to need those for tomorrow's lesson as we move forward to factoring. I'm going to place some tiles in front of you, and then I want you to write me the polynomial on the screen that you think I'm showing you. Here we go. That's a blue square. 2 green rectangles and 1 yellow little square. Think back. Remember when I introduced adding polynomials with Mr. Q's pet shop? Remember that? And then right after that I showed you with tiles how to combine like terms. Do you remember what I have in front of me? Write it on your screen, send it in. Okay, just put it away. Everybody send that in? Okay, good. Alright. Look up to the screen. Who remembers that this one was labeled, since we didn't know the measurement from here to here or from here to here, I said from now on we're going to label this one x squared. You guys remember that? This one was x times 1, so this one is known as x, and this is another x. And these are units. This is considered a 1. So what is my polynomial here? X squared plus 2x plus 1. Is it coming back? Okay, how about this one? What if I flip this one and I flip the little one? What does that mean? Talk it over to your neighbor if it's in red. What does the red mean? That is correct. This is a what? Negative x squared, and this one's still a positive 2x, and what is this one? Minus 1. So far so good? What if I did this? Switch this one, flip these, and switch this one. Tell you never the new polynomial now. That is correct. X squared minus 2x plus 1. So for tomorrow, we're going to be using the tiles to get ourselves going with a new lesson. So log off from Nearpod. And for tonight, you're going to practice more factor by grouping, and that's on page 531. 531, sorry.
For tonight.
For tonight, not fortnight. 531. There is tutoring. If I don't see you guys tomorrow. Enjoy your home play. Bye.